I want to study with my brother, but he's hundreds of miles away from me, a bit too far to meet halfway at some random coffee shop. Instead, we hop on a Discord call, with one of us screen sharing a Microsoft Paint window. Sometimes, we want to draw on the canvas at the same time. Despite the many online solutions already existing, the prospect of creating a project that's actually useful appealed to me. There are two ways to approach this problem: centralized, where a single web server handles the distribution of data, and decentralized, where data is stored and distributed by the users. Centralization has many advantages, like content moderation, advanced features, and lightweight front-end, but it comes at a cost. Running servers is expensive and can possibly result in high latency for those far away from the central server. Decentralization, on the other hand, is cheap and scalable, but content cannot be validated by a central server. Luckily, the downsides of decentralization don't really apply to a Paint app, since the only data transferred is the position and colors of the lines. The engine behind a decentralized application is called WebRTC, a widely adopted standard for peer-to-peer connections. First, party A creates an offer, which are instructions for how to connect to that party. The offer is then sent to party B, who forms an answer, telling party A how to connect back to party B. Once the answer is sent back to party a direct connection is opened between the two parties. This connection does not pass through a server and has relatively low latency. But how are the offer and answer communicated between each party? This is where signaling servers come in. Each party connects to the signaling server, which remembers who has connected. Party A asks if it can connect to party B, and the signal server will relay the offer to party B. Once party B has formed an answer, it is relayed back to party A through the signaling server, and then a direct connection can be made. Unlike central servers that process all data, signaling servers cost next to nothing. They're so cheap that there are many free options available, including those run by the group behind PeerJS, a library to handle signaling server interactions. When party A connects to the PeerJS signaling server, the server responds with an ID. Party A turns this ID into an invite link. Party A then DMs the invite link to a friend, who clicks the link and automatically connects to the signaling server and goes through the process to connect to party A. Party A can keep sending the invite link to more friends. When they connect, they also receive instructions on how to connect to the other people involved. In this case, party C receives connection instructions to party B. As more and more people connect, this process is repeated to form a fully connected graph. Now, you might be thinking, what about the painting? With this connection setup, each person stores their own local copy of the whiteboard. When someone makes a change on their local board, they broadcast their changes to the others, who make the corresponding change on their copies. This distributed setup allows for large canvas sizes with very little network usage. Let's talk user interface. Written with TypeScript and the Svelte framework, the front-end design is laughably simple. It consists of a button, which copies the invite link to your clipboard, the canvas, which you can draw on, and a palette for choosing colors and brush sizes. The majority of the code was on the network size, organizing the construction and modification of the peer-to-peer connection graph. In the end, the setup both worked and was satisfying. It is currently deployed, so make sure to go check it out with a friend. The brothers, far apart, now study together, solve together, laugh together, and paint together.